Every car you drive has a blind spot. Not just one, but many. In fact, you'd be surprised at just how much space you can lose sight of when changing lanes or reversing. Think about it, and consider what you might not see. A motorcycle in the next lane, a cyclist, a passing car perhaps, maybe even a truck. A study from NHTSA shows that most of the changing lane accidents are related to distraction or lack of visibility while driving. In order to avoid this, our group designed a prototype. Our idea was to amplify the field of view of the driver. To do it, 3 cameras were used. One in the right, one in the left, and one in the back for reversing. The camera angles are really wide, so it can cover a lot of the blind spots. 2 motion sensors will be used to detect any object close to the car. In an overtaking situation, for example, the sensor will detect the car and then turn on the camera. A study made by a transportation research group classified 28% of the US major roadways as in poor condition. These numbers can get even more impressive in other countries, such as in Brazil, where 62% of the roads are considered in regular bad or terrible conditions. These roads that usually are lacking maintenance often propitiate the creation of potholes, costing an annual average of around $280 for individual drivers. Our approach for pothole problems in roadways would be a combination of technologies already available or in development today for a more efficient system. Technologies such as forward continuously controlled damping and Jaguar Land Rover's cloud-based system. Another problem found in roadways worldwide is running over animals. In the US, the number of deer-related vehicle collisions in a single year is estimated to be around 1.23 million, causing more than $1.1 billion in property damage and around 200 human deaths. Our approach for animals in roadways would be another combination of 2 different ideas. In both of them, the animal crossing the road would be detected with infrared and heat cameras. Then, one option is to focus the car's red light in the animal's body so it freezes, while the other option is to focus UV light beams in the animal in order to scare it. In both cases, emergency brakes are pre-charged and a cloud-based SOS alert is sent to other vehicles nearby notifying the danger. Drowsy driving is an underestimated but huge factor in road accidents that can even put lives at risk. The US government estimated that a total of 100,000 vehicle crashes each year are caused directly by driver drowsiness. This research analyzes several current approaches to detect and avoid drowsy driving. First, we present a psychological approach, which uses heart rate, skin conductance, and brain activity as a measure to drowsiness, as well as devices and wearable technology that can be used for that purpose. Behavioral measures study the body movements, like the eye blinking, yawning, and head pose. Cameras and sensors are used to identify these movements. Also show they currently work on Google Glass, which has applications that were made specifically to detect and alert drowsy drivers.
Wake up. Perhaps you should find a rest area.
We can also fight drowsiness by not only detecting it, but preventing it. We explore light, sound, and speech-based solutions for drowsy driving prevention. Blue light has effects similar to caffeine on the human body. Different sound pressure levels can alert the driver. Automatic generate speech can create a conversation with the driver, and computer software can identify drowsiness by analyzing voice patterns. All of these solutions need further investigation in practical ways of implementing them in a reliable, cheap, and non-invasive method to fight drowsiness. Finally, we propose that the combination of these different approaches into an integrated solution should be the subject of further studies.